So today we're going to start right at lesson 3 where we left off. So we're going to do tangent, which we didn't really do too much with yesterday, and we're going to do more with your ASTC. Is everyone feeling okay with the ASTC so far and everything I gave you yesterday? Okay. Again, I gave you a lot of foundational information for sure, just because that's the deal with the trig. It starts and it just builds and compiles. And today is going to be very, very similar. So we're going to start right on the top of day 3 here. So we're going to do your tangent function and all your sines again. So since on the unit circle, cos theta sine theta is a way to write your unit circle, we can represent the lengths of the sides of a right triangle like this. So we're going to sketch a picture. All right, so right here, I would like you to draw in your 4 quadrants and do your best and draw a circle. I know it is easier said than done. And I would like you to inscribe a right triangle into quadrant 1. So right here, I want you to go like this. So right triangle coming right off the origin, and then your altitude right back down. And if you can squeeze it in here, please, I want you to place theta right here. Okay. When we discussed the unit circle yesterday, what was the radius of the unit circle? Do you guys remember? Yep. Good. So this is 1. So this was 1. And then we also discussed that on the unit circle, the x value coincided with what? Cos or sine? Cos, yep. It's usually like the opposite you would kind of think there. So this is cos theta. And then my altitude right here would be sine theta. All right, so just like that. So what we're going to do is use this to get tangent. So if I told you that I would like you to find the tangent of theta, then we discussed yesterday that tangent is equal to opposite over adjacent. So what I would do is fill those in. So tangent of theta is equivalent. What do I plug in for the opposite side? Yep, sine theta. And what do I plug in for the adjacent? Cos. Excellent. So what did you just show? What's tangent? Sine over cos. Yep. This is an identity. So tangent is equivalent to sine theta over cos theta. Comes right off your unit circle. Okay? So that's why we didn't find that yet yesterday, just because there's a little bit more legwork that goes into finding tangent. So we will do that right down below now. So I gave you some more unit circles in your example below, and we are going to find the coordinates of point P on the circle and find sine theta, cos theta, and tan theta. All right, so on my unit circle, sine theta is which one, x or y? This is my y value. So the sine of theta is -3 over 5. You know what, let me calculate this. This is a little bit too far off. Go ahead, guys, and write down cos theta. Come on. Okay, or not. Never mind. I guess I just have to make do it, won't do it. So cos theta is equal to -4 divided by 5. And then I want to do tangent of theta. So tangent of theta you now have to calculate. So tan is sine divided by cos. So we can do this by hand, or you can use your calculator because this one has no radicals. So to be clear, that's why you could use the calculator. So I'm going to do sine over cos. So I am going to do -3/5 divided by -4/5. And in my head, I'm thinking to myself, keep, change, flip. So this would be -3/5. And then times, flip it, 5/-4. What happens to the 5, guys? Cancels, exactly. So your 5s are going to cancel, and you are left with -3/-4, which is just plain 3/4. Okay, so tangent just has a little bit of extra work that you unfortunately have to do to get that answer. All right, over to my next one. I think my next one has radicals in it, doesn't it? Yeah, so this one you can't use the calculator for. We're gonna have to kind of do it by hand. So I am going to do first sine theta. So sine theta is the y value. So the y value is the square root of 33/7. Cosine is 4/7. And then tangent is equivalent to sine divided by cos. So I'm going to do that over here so I have a little bit more room this time. So I do the square root of 33/7 divided by 4/7. And then I do keep, change, flip. So square root of 33/7 and then times 7/4. Your 7s cancel again, and then there's your answer. And it's okay to have a radical on the top, just not the bottom. So tangent is equivalent to radical 33/4. How are we feeling so far? Pretty good? It is. Yes, you just prove y right off of that unit circle at the top there. Yes, that is an identity that is always true. Absolutely. So next, in the bottom section, we are going to find the quadrantal angles from the unit circle. So we need to sketch one of these. I'm going to do this. I'm going to erase this and we're going to place a unit circle in that spot. Because now we got to add tangent to the mix. All right. So draw yourself a circle. And here's how you set up the unit circle. So 0, 0 is the center. The radius is 1. So I go over. And this is going to be my point 1, 0. Back to the center. This would be my point 0, 1. That's 90 degrees. This would be my point here, -1, 0. That's 180 degrees. And then this down here would be 0, -1, and that is 270. All right, let's see that artistic ability. You guys much using the compasses? Not so much? All right, that's kind of a circle. Or like an oval, but it happens. All right, so now we're going to go and calculate these. So sine of 0. Sine of 0 is equal to 0. Cosine of 0 is equal to 1. Tangent is sine divided by cos. So 0 divided by 1 is equal to 0. There you go. So now you just added one new part to that. Sine of 90 degrees. So now the next point is 1. Cosine of 90 is 0. What is special about tangent of 90? Nope. Yes, very good. It's undefined. Awesome. We cannot divide by 0, so tangent of 90 is undefined. 180 degrees, so the y value there is -0. And then the cosine of 180 is the -1. And then 0 divided by -1 is 0. Yep, so this one's okay. Just like that. 270 degrees, the y value is -1. X value is 0. Is there an issue again? There is. So we can't do that. So the tangent of 270 and 90 are both going to be undefined. Okay. So there we added on tangent to your unit circle. You guys still feel okay with all of that? Okay. So moving into your ASTC, again, adding a couple more pieces into the mix here. So first you're going to label all your quadrants again, just in case. So they go 1, 2, 3, and 4. And does anyone remember from yesterday which trig functions are positive in the first quadrant? All of them. Excellent. They're all positive here. That means all 6, sine, cos, and tan, and their reciprocals. Okay. In quadrant 2, which one's positive? Sine. And what's the reciprocal that goes with sine? Does anyone remember? Good. And cosecant. Excellent. Because those go together. So just so you're aware, those will also be positive. So sine and its reciprocal function. You guys don't do a ton with reciprocal functions this year, but again, just to give you a basis for next year. Next quadrant. Who remembers? Tangent. And what goes with tangent? Cotangent. Good. Last but not least, which ones are positive in the fourth? Cosine and secant. Excellent. Cosine and its friend secant. So reciprocal function goes with it. Everything else is negative in those places. Okay. So in quadrant 1, we said that they are all positive. And again, I'm adding the reciprocals into just so that you work with those as much as possible. In quadrant 2, only sine and its reciprocal. So I'll add that too. In quadrant 3, only tangents. And tangent pairs up with cotangent as well, so don't forget about that guy. And then in quadrant 4 is cosine. And cosine goes with secant. There's many ways you can remember this, the ASTC. I don't know how creative people are feeling in here today. So do this. So here's A. Here's the S. Probably should put a T here. And then here's your C. So we typically say all students take chemistry, all students take calculus. If you have something better, by all means, please use it. So we remember by saying all students take chemistry. Okay. Again, you're welcome to come up with something better if you would like. So moving on to 12, we're just doing more work with ASTC. So it says state which quadrants satisfy these conditions. So where is cosine positive? And again, I'm going to do one of these down here too, because it's helpful to have it right next to you. So cosine is positive where and where, guys? Good, 1 and 4. So quadrant 1 and 4. And then where's sine negative? Yep, 3 and 4. Awesome. So below the x-axis, so 3 and 4. Remember, make sure you're using those Roman numerals. Next, it says if sine is less than 0 and cos is less than 0, where are we at? So sine is less than 0 in quadrants 3 and 4. and cosine is negative in 2 and 3. So what's the answer? Very good, the repeated quadrant. So this would be quadrant 3. Good. All right, more of the same thing. So where are we at if tan is less than 0 and sine is less than 0? Very nice. You did that quick. And if you can't, that's fine. You don't have to show all the little figuring on the side. We want cos to be negative, so that would be 2 and 3, and tan to be positive, so that would be 3. Next, we want tan to be positive, so that's 1 and 3, and we want sine to be positive. So where's the overlap? 1, good. Now this one's a little trickier. 15 says if the value of sine of theta times cos of theta is negative. So you have to think about how can that happen? How can I get a negative number? A positive times a negative or a, yep. So these are the two cases you're going to look at. So where is sine positive but cos negative? Quadrant 2, good. And then where is sine negative but cos positive? 4, good. So it's like case 1, case 2. Okay. All right, 16, who remembers? Where is tangent undefined? Excellent, 90 and 270, choice C. Awesome. Questions on any of that so far? Good, let's keep building. Now you get to do some drawing. I guess more drawing because you already kind of have them. All right, we are going to discuss what is called a reference angle. So you're going to draw what I like to formally call the bow tie triangles. So they kind of look like a bow tie if you do all of them together. And when you go to find a reference angle, there are different rules depending on the quadrant that your angle terminates. A reference angle, by definition, is always between 0 and 90. This is between 0 and 90 degrees. So that means that the rule for quadrant 1 is that there isn't a rule. You just use the angle because it's already between 0 and 90 degrees. So I just write theta because I don't have to do anything at all. Now you're going to make use of that wonderful geometry knowledge that you've acquired from the past. In quadrant 2, I have 180 degrees because of this straight line. So straight line adds to 180. So my rule is I do 180 minus theta to get the reference angle. In quadrant 3, I am adding on to 180. So you want to kind of think of it like this. You're going to do theta minus 180. So you just have to flip it around. And then the last quadrant, we use 360. So we do not make use of 270 in any of these. So this would be 360 minus theta. And those are your rules to find a reference angle. Again, no 270. We think straight line or full circle. All right, so below, we are going to draw each angle and label it theta. Draw a right triangle and determine the measure of the reference angle. All right, 160 degrees is going to terminate where? Quadrant 2. So I draw it like that. And now I'm going to go and find my reference angle. So my reference angle in quadrant 2 is 180 minus 160, which is equal to 20. And then check it. Guys, is 20 between 0 and 90? Then you're good to go. That's it. Next, 250. 250 is a positive angle. It rotates counterclockwise into quadrant 3. So here's my little picture. Here's my triangle. And what is the rule for quadrant 3? Minus 180. Good. So I do 250 minus 180, which is equal to 70. Does it work? It does. Okay. 80 degrees. What quadrant would that fall into? Quadrant 1. So do I need to do anything at all? No, it's already between 0 and 90. So it's already by definition a reference angle. Done. No work to do. All right, my next guy. So I have negative 142 degrees. So I'm going to rotate the other way. So I do this. Looks like this. And how do you think I make it positive? Add 180. So you're just going to do the opposite. So this is equal to 38. All right, next, negative 40. So that's going to drop me just right down into quadrant 4. And it's very similar to a first quadrant, but because it's negative, you just want to think about taking the absolute value of this. So if you want, you can write it. So absolute value of negative 40 would give me 40. Yeah. All right, back to a positive. 317 is all the way into quadrant 4. So that's over here. And the rule for the fourth quadrant is 360 minus 317. You guys do that without a calculator? Well, I guess you have a calculator in front of you anyways, right? Equal to? Good. Yep, so 43 is your reference angle. All right, a couple more of those. And then we're going to add on your trig function to the mix here. All right, so number 7, I have negative 330. So I'm going to rotate the other way. And this is going to place me all the way into quadrant 1. How do you think I turn this into a reference angle? Excellent. Yep. Kind of intuitive. Yep. So negative 330 plus 360. Awesome. Does it work? What do we get? 30. Yep. So you're between 0 and 90, so we're good to go. Back the other direction now. So positive. So 170 is going to be here. What's the rule for this one? Good. Subtract from 180. So I do 180 minus the 170, which is equal to 10. Yep, so just like that. And this is another process that you're going to build upon in a minute. 196, that is all the way in quadrant 3. So here is my triangle. So I'm going to do 196 minus 180, which gives me 16 degrees as a reference angle. Okay. So we are going to extend this a little bit further, just a little bit for today. How do we feel with the process of finding the reference angles, okay? Okay, and whenever it says to draw a picture, that is what it's referring to. These are all what we call angles in standard position. So they always, all 4 of them together kind of look like that bow tie again. It's like when you were looking for vertical angles in geometry. All right, so what you'll notice I did here is basically added one thing. in front of the angle, you now have a trig function. So your task is the same. You're going to start by drawing the right triangle. You're going to determine the reference angle. That's the same. Then what we're going to add on is whether or not that trig function is positive or negative there. And we are going to express it as a function of a positive acute angle. What does acute mean? Awesome. Yep. So it just means it's between 0 and 90. Good. Eventually, we'll get to the questions where you find exact value. Actually, if any of these work out nice, I might make you do it just to kind of get you used to it. So 100 degrees is where? Okay. Now I find the reference angle. So I do 180 minus 100, which is equal to the sine of 80. And now what you're going to add on to this is ASTC. Is sine positive or negative there? Positive. So I'm going to place a positive in front. Clearly, you don't have to do that, but what students typically do with these problems is that always gets forgotten. So I always add it in there just to try to prevent people from skipping it. So 190. So 190 is going to go all the way into the third. So I'm going to do 190 minus 180, which is equivalent to the cosine of 10 degrees. I'm going to do ASTC. And what do we need to put in front of cosine? Awesome, a negative. And again, a lot of this is not hard, but it obviously is continuing to build. So be careful with your steps. You'll see I try to always do them in the same exact order for consistency. So tangent of 320 goes all the way over to quadrant 4. So I do 360 minus 320, which is equivalent to the tangent of 40 degrees. And then last I go ASTC. And this needs a negative. Okay. How do we feel so far? Pretty good? Mm-hmm. Yes. Mm-hmm. It does. Yep. It always gets drawn the exact same way as those. Yep. So the radius always comes off of the origin, and then it always goes perpendicular to your x-axis. Yes. Excellent question. Yep. You guys are only working with right triangle trig at the moment. Actually, this whole year. Your course before Common Core used to do the non-right triangle, but we don't do much trig with you guys anymore. We do a lot more stats, believe it or not, than trig. All right, so 13 is one I'm going to have you continue with, and you'll see why in a second here. So 150 is where? All right, so I'm going to do 180 minus 150, which is the cosine of, good. I'm going to go ASTC. And cosine is, good. Now, you are not asked to do this yet, but this is what we lead into next week. 30 degrees, isn't that familiar? Didn't we talk about a triangle with this yesterday? So this is a question that next week is going to go further and ask you to now find the exact value. So someone impress me, what's the cos of 30? You want to remember? You are so close. Anybody? Radical 3 over 2. So that's what we kind of lead into. Okay, so again, it just keeps on building. All right, you don't have to do that now, so it's fine. It didn't ask for it anyways. All right, negative 20 degrees would plop me down right here. And my reference angle, I take the absolute value of that. This is 20 degrees. And I'm going to do the sine of 20, which we don't know. You only know like your 30, 60, 90, 45s, unit circle stuff. And then ASTC means what goes in front of us. Good. Yeah, I deliberately didn't give you too many that actually did go further. All right, cosine negative 165. That means I go this way. Not quite 180, obviously. And then to make this positive, I do negative 165 plus 180. So just flip-flopping your rule. So this is cosine of 15 degrees. And cosine there is negative. All right. Questions so far? Okay, we're getting there. So 245 degrees is going to be quadrant 3. And I'm going to go 245 minus 180, which is equal to 65 degrees. And guys, is sign negative or positive there? Negative. Excellent. And again, that gets easily forgotten. Happens every single year. You guys know how to do it, but it just gets left off. All right, last couple. Tan of 163. That's here. So I'm going to do 180 minus 163, which is equal to the tangent of 17 degrees. Positive or negative, guys? Negative, good. And again, I'm making that my last step every single time. And lastly, cos of 340. All the way over here. And I'm going to do 360 minus 340, which is equal to 20. Because again, I didn't give you anything else you could actually do exact value for. And in quadrant 4, cosine is positive. Okay. Again, I gave you a lot this week. So I want to give you an opportunity to get started on some of your assignments in case you should have questions. So on any of those so far, do you have any specific questions yet? Okay. I'm sure it goes without saying, do the 2 homework assignments before the quiz, okay? And on the quiz, obviously, take your time, be careful those positive negatives. We discussed yesterday, no midterm this year. Okay, so do a good job with all of those, and we will continue building on your trig next week. So you have 2 Delta assignments due by Friday and the quiz due by Friday. You may absolutely take your remaining 15 minutes, get a good start on those. And again, if you have questions, please reach out, as I know you will.